Cool. Head on, guys. So today, carrying on about home inspection stuff, today we're going to talk about like different types of components in homes, kind of clarify some different terminologies and just answer your questions on what components are. So this is something Ben reach out to you guys and give me some terms that agents don't understand. So the point of this is just so that you guys are writing repair amendments, looking at them, you kind of understand what it is. So this isn't going to be super long, but it is open to questions. So before we get started here too much, do you guys have, like, this is mostly for you guys, the feedback. So are there things you guys see on repair amendments that you guys don't understand what they are? Like this, what is this component? You know, what does this mean? Like, what does an AFCI mean? Or what is a purlin? What is a joist? What is a strap? That kind of stuff. Do you guys have any of that stuff that you would like explained a little bit?
Oh, most of the time you back it up the picture, don't you?
I do, yes. You guys don't all get what I have. So, and then sometimes if you guys get a repair request from a buyer, there's not always pictures associated with that, right? So, what we're going to talk about is some of those things that are there. So first thing I'm going to touch on is the difference between AFCIs and GFCIs. So AFCIs and GFCIs are safety devices that can either be an outlet or a breaker, and it is something that's required by modern electrical code, right? So AFCIs started getting introduced in the early 2000s. GFCIs have been around since the 70s. I don't think they're around in the 80s. So GFCI stands for a ground fault circuit interrupter. And so what it is designed to do is that if it senses a improper ground in the system, it's going to trip the breaker or the outlet and shut the power off. Generally, that is done by contact with moisture. So it's going to do that. So we want those in areas like kitchens, bathrooms, laundry rooms, garages, crawl spaces, exterior outlets, that kind of stuff where there could be potential moisture contact. And that's the only way to protect you from something that's plugged into those circuits. So you've got an extension cord plugged in and it hits water, or it's a break in it, it's going to sense a faulty ground and it's going to trip that breaker. So AFCIs, like I said, started showing up in the early 2000s and are required in most places now inside of a home. So living rooms, hallways, bedrooms, combos are designed in required for different places also. So AFCI stands for arc fault circuit interrupters. And what they're designed to do is to sense small arcs or loose connections in an electrical system. So they're designed to sense what is called milliarcs, which is something that we can't even see or feel. But milliarcs are what has been linked to several types of electrical house fires. So these are there to help protect stuff from bad devices, all that kind of stuff. So AFCIs are very sensitive. So that means that like even like old Kirby vacuums will trip those. So they got a big old electric motor, when it fires up, it actually arcs inside the motor and it'll trip it. So you've got old appliances in your home, you have clients that have old appliances and they plug them in, old vacuums, and it keeps tripping the breaker. It may not actually be the breaker. It may be the device itself is creating too much electrical current and arc inside the motor when it fires up that electrical motor. So a couple things too about both modern AFCIs and modern GFCIs is they're very sensitive to tripping when power is removed. So where that affects us drastically is when we have power outages, your automatic generator kicks on. In that time gap between when the generator kicks on and we lose power, a lot of times those breakers will trip off. Where that can be an issue is if your furnace or your boiler is plugged into a safety breaker and you're out of town. So last year I looked at 5 houses that this happened to people on vacation last January. They were out of town, generator kicked on, the garage heater turned on, they had glaciers on both floors because nobody checked on the house.
Do you ever, in your reports, do you recommend like, you know, I know that it's code that you need a GSCI for like the furnace to be plugged in inside the garage, right?
Yes, it does. So I do not recommend going against electrical code in these places. There are ways legally by code that you can hardwire your furnace where it does not require a safety breaker, but that's an electrician.
I'm just saying like in a note or something at the bottom of that saying that, you know, if electric goes out or if the power goes out, your furnace is connected and you're not home.
Yes, we do talk about that to check on it. Yeah, definitely. That's something I talk about with all those kinds of things. So One of the things we get power outages, check on those things. Especially the AFCIs, they don't have a real long life as a breaker, just because they have a little computer chip in them. They tend to go out a lot faster than the older style breakers and stuff like that. And of
How
course,
long is the life?
5 to 10 years, depending on how much use is on the circuit and stuff like that. So, that does not mean they don't go bad. They're also a very expensive breaker, which is really dumb, in my opinion. But anyway, they're there and they're part of our deal. So something else, gonna touch on electrical stuff that started showing up in 2022 is whole house surge protectors. This is something else that you guys will probably start seeing getting called out on inspections a little bit more that are missing. These are extremely important for homes. The main reason for that is a lot of our modern cooking appliances and heating appliances, you have to treat them as delicate as you would a desktop computer. It's because they have all the Bluetooth, Wi-Fi capabilities. So that whole house surge protector is installed. And what it does is it gives you surge protection on your whole home. So these are something else that you guys need to start seeing. There's a little box with a light on them. It goes either on the main
How
disconnect.
expensive are
I think they're about $200 a piece. But
Geez, how many do you need in a house?
and I don't know the lifespans on those. I haven't found a dead one yet, but they've only been around for 4 or 5 years now. So,
Do you have any brands that you would recommend or that you see the most?
I really like Square D and
what do you say, square D?
Square D and Eaton panels. I've seen the best. I know that the Siemens brand breakers tend to not last as well. But there's no major like fire faults or anything like that with them. Just what I've seen is that the Eaton and Square D panels tend to last a little bit better.
How long do they last?
I mean, there's still Eaton panels from the 70s that are working just fine now.
Interesting.
Yep.
Eaton.
Eaton, yep, Eaton, and they would also be called Cutler Hammer. They're the same company. They're tan panels and they're awesome. I love still seeing them.
So, I mean, if we're replacing those with a newer one, so the old one taken out, or is it attached to it so it goes through it?
The surge protector or the surge protector is not a required retrofit. It is only required from 2022 forward. So it's not something that has to go into an older home. So with electrical code, you are not required to update an electrical circuit to modern code unless there's extensions made to the circuit. And that is wiring. That's not a device or a light, right? So if you have an older 80s home and it's still got all the same fixtures and switches and nobody's put extensions on it, it's not required to be brought up to modern electrical code that we have for 2026. Right. So that's something else for you guys to remember, especially with older homes, like 50s and 60s houses in Anchorage, where sometimes those panels were put in kitchens and in bathrooms. That's something that a home inspector is going to call out as a health and safety thing, but it's not necessarily something that by code has to be updated. Now then, if there's damage to the panel, rust, corrosion, that kind of stuff, like that's different. But, so that's something that's important, members, you guys do negotiations on older homes, is that,
So grandfathered in essentially.
yeah,
I've got a situation right now with the two of the bedrooms are egress.
so fire code does not grandfather well. So there's some things about it that does, but like smoke alarms and CO detectors, like there's no grandfather with that. There are some grandfather clauses, starting from 1979 and older with like sill height on windows, like it can be 48 inches, not 44 inches, that kind of stuff. But the window sizing, to the best of my knowledge, and the hardware stuff, there's no grandfather clauses on that kind of stuff. So,
This surge protector is installed in the electrical panel.
yes. Yeah. Yeah, let's took my other notes here. All right. So we'll talk about water heaters. So, you're gonna see 4 types of water heaters generally inside home. You're gonna see like a standard tank, natural gas or electric water heater. You're gonna see a sidearm water heater, which is gonna be something that's powered by a boiler. You're gonna see on-demand water heaters that are standalone unit, and you're gonna see combi boiler water heater units, which are the same thing. So natural gas and electric water heaters, everything look like 50, 40 gallons tall cylinder things. So those are. On-demand or tankless water heaters are gonna be a smaller box. They'll be about 3 feet tall, about 2 feet wide, about a foot deep or so. Those right now are my favorite water heaters. Mainly because they still have long warranties on them. They're pretty energy efficient, and they're also very rebuildable. So a lot of the old tank water heaters, when they go bad,
They're done.
they're done, right? Sometimes you can replace a burner in the bottom
From the bottom, that's it.
and toast.
So,
Also the lifespans on those pandemic to now is drastically shorter than older ones. I'm seeing a lot of them that are 5 to 7 years old that are already rotting out, which is not great because
Yeah.
they should last a lot longer than that.
well, some of them are $1,200, 2,000. I mean, they're not that cheap.
They're not so cheap.
Does that have anything to do with the type of rod that's on it? And
I think the rod's part of it. I think a lot of it is that they're just using cheaper steel when they built the tank. Yeah, that kind of stuff. So sidearm water heaters. Sidearm water heaters are my second favorite type of water heater. And what they're used in conjunction with a boiler system. So what they are is they're a big tank, and inside that tank, there's a radiator that hot water flows through from the boiler. And then your domestic water circles around the outside of that radiator, and that heats your domestic hot water that comes out of the tap. What I really like about these is that they're very energy efficient also. They're also super low maintenance as far as water heaters go, because there's no heating element or burner assembly like on a water heater or a gas one for it to burn out. It's just a radiator that sits in there, which generally lasts a really long time. It's not uncommon to see 20, 25 years out of a sidearm water heater. So
What's the normal volume that you, in other words, is it continuous because it's coming from the boiler? Or is it,
it's not
like boiler maker?
So it's recovery rate is gonna be between like an on-demand or a tankless that you can run for forever and it never runs out, and a gas water. So they recover a lot faster than like a tank water heater. In one of my personal buildings, I've got a triplex with 5 bathrooms, 3 laundry rooms. We have a 35-gallon sidearm water heater, and it keeps up with everything just fine. Right, so it's super good unit, and they work really well. And then combi units. So combi boilers are becoming very popular. Some of them are built much better than others. The Navian and Rheem ones and the lock and bar ones are built pretty good. I'm going to touch on triangle tube boilers here real quick. So triangle tube was a very popular brand of boiler for a long time. There's a lot of our fourplexes that have them in it. Byler built a lot of them with them. They were very cost-effective boiler. Triangle tube is now out of business. So finding parts for those boilers can be very hard now.
What was that name again?
Triangle tube. So just something for you guys to be aware of, as those boilers are needing components, those parts are going to get more expensive or being unable to find altogether. So combi units. So a combi unit is a boiler and a water heater in one unit. They're usually a wall mounted unit, about twice the size of a standard on-demand water heater, and they're pretty good units also. I have seen issues with really cold well water where the water heater side has a hard time keeping up with a lot of use inside of home because it's a pretty small heating jacket that they use. It's about that big. But they are good. They're a lot like the on-demand, where they're very modular in their parts. You can get parts and components to replace them. A lot of those still come with 15 and 20-year warranties on them also. So those are our main types of boilers, or water heaters and stuff like that. The easiest way to tell an on-demand from a combi unit is when you're looking at the unit itself. Coming out of the bottom is going to be your water lines. So a combi unit is going to have at least 4 sets of lines, sometimes 5. And then a standard on-demand is just going to have 2. So that's, if you're looking at them, you're like, what kind is this? You're going to see 2 pipes. It's going to be an on-demand or a tankless. If it's got 4 or more pipes, it's going to be a combi unit. This is also going to be your boiler that heats the home also.
I've had a couple clients that they had a holding tank prior to it going into the on-demand.
Yes.
Because the cold water was destroying
Yes.
the on-demand hot water heater. I've had 3 clients actually in a row that were like back to back. So I was like, really, I've never heard that. And then the next client I had was like, yeah, we ended up making a holding tank because the water was coming in so cold. We couldn't figure out why it was destroying the hot water heater. It was the actual water coming in from.
Correct. Some of the older on-demands, particularly from the early 2000s, when that burner would kick on, what it would do is it had to burn so hot, so intense to heat our well water that it was starting to destroy those heating jackets. So I haven't seen that with newer units. And what Nick's talking about here is called a tempering tank. So what it is from the well, your water comes into this tank. Sometimes that heating element, sometimes they'll just sit there and they'll warm the water up to room temperature. and then send it through the tankless water heater so that it's warmer and the burner doesn't have to work as hard to get it ready to come out of the tap. So if it is something with a real deep cold well or something you're talking about like that, where it's an older unit, it's super useful. And that can be, there's a lot of different ways. I've seen people use old water heaters, pressure tanks, all that kind of stuff to just build these tempering tank systems and stuff like that. And they're pretty simple to get installed by a plumber. They just put them in line on the cold water feed side from the well to the water heater.
What size would you recommend? 20, 30 gallons? Did I have enough?
At least 30 gallons.
At least 30.
Yeah. And I mean, and it depends a lot too on the house and how much is in there. If you've got a family of 5 or 6 that's doing a bunch of laundry, dishes, showers, you probably want to push that to like a 50 gallon tempering tank.
My client had
Yeah.
the second one, then the big hot water heater he used.
Yep. Okay, we're gonna talk about crawl space ventilation. So this is something that is a big deal here in Alaska. A lot of it is to fight condensation that gets built just between our temperature differentials between the inside and the outside. So in the wintertime, we got cold outside, we got warm inside, and that builds us moisture, right? So 3-star energy rated homes and older did not require mechanical ventilation in the crawl space to keep it dry enough. And a lot of that is because with 3-star energy rated homes, we weren't sealing vapor barrier, and it was just the construction was not as airtight. So the times that stopped as standard building practice is going to be in the 90s. And then from the 2000s on, we started sealing vapor barrier, building better windows, and building more airtight homes. We got our 4-star, 5-star, and even now our 6-star energy rated homes. So with those 4-star and better energy rated homes, there needs to be mechanical ventilation in the crawl spaces, because the older style crawl spaces had what was called passive ventilation, which are those old style crawl space vents that you push open in the summer and then you close them up in the fall. Passive vents created enough airflow for the older homes. They would ventilate through and they would get that moisture and that condensation out of the crawl spaces. As we've gone to more airtight homes, sealing them up, making them tighter, it was found that that was not enough, and they were building microbials and other issues in the crawl spaces, mainly microbial issues with stuff like that. So what they did is they install mechanical ventilation. And this is a pretty simple thing. So what they do is they take a super high CFM, which is cubic feet per minute fan. That's how much air volume it will move in a minute. And they'll install it in the crawl space on a moisture sensing switch, either built into the fan itself or an ancillary switch that's installed next to the fan in the crawl space. So what that does, you're going to set that at somewhere between 20 and 30% relative humidity. And that fan is going to auto-regulate the crawl space and ventilate it out. So you do not need makeup air to come into the crawl space to keep up with that fan. We did that for a while here in Alaska, and we realized that we were bringing in too much outside cold air into the crawl space, and it was actually creating more condensation issues. So what they rely on is that fan is going to put negative air pressure or a vacuum on the crawl space, and it's going to pull warm conditioned air from the home down into the crawl space. That dry air is then going to go through the crawl space to the fan, pick up moisture, and then get blown out of the house in the crawl space. So this is a good practice for a couple of reasons, but the moisture control, obviously, and also what it does is it keeps you from getting anything from your crawl space coming back up into the home. So crawl spaces are not held to the same standard as regular home as far as like finish grade and all that kind of stuff in the inside of it. So there's a higher potential for there to be air contaminants down there, either dust, microbials, that kind of stuff. And if you can control that by putting the home under the crawl space under negative air pressure, so it's sucking from the home down into the crawl space and then blowing it out, you're going to have a lot less issues with stuff and odors coming back up into the home. So like that musty smell we get when we walk into 80s houses, modern homes don't have that. And a lot of that is due to that ventilation in the crawl space, keeping that crawl space odor blown out of the house and stuff like that.
Is there anybody that locally that installs them?
Yeah, a general handyman can do it. It's super simple. So you go to Lowe's, you buy a $200 fan, you buy $60 worth of ductwork, and you're done. Like it's a couple hour project.
And
And
I'll chat about that, but when I first bought my home up here, it was the first 5-star home.
Mhm.
Okay. And I quickly used the word bullshit. And said, because there was too much moisture, and so I had my contractor at the time go in and we pulled all the insulation out, put brand new dry insulation, no plastic. We put a series of fans down there and we'll open and close them in the spring, put the fans, and everything works fine. But having something set up with what you're talking about makes it a little simpler than, if I do that, I don't have to open and close them all.
Correct. Yeah, you would actually seal off your old foundation vents with rigid foam and spray foam and just like discontinue them in place. So that you're not pulling that colder air in the wintertime into your crawl space and creating more
It
condensation.
sounds like a simple fix to me.
Super simple.
It's
Super simple.
goodness.
Yeah, so that's those.
Yeah. Simple is good.
You don't have to word BS words.
Look full at times though.
Oh, it's very good. Not used enough as far as I'm concerned.
Agreed. Agreed.
I quickly found out from about Stephanie, yeah, it's pretty good.
Oh, we know.
Totally unexpected. First time she did, I turned beat red. She got me.
Okay.
Conditions on her face or anything.
Oh, I should have said that for a
All right, so, I'm gonna touch on radon testing a little bit here and radon mitigation. So, radon is a gas that is created, deep down in, forget which sub layer of the earth, radioactive material when it breaks down. So that radon gas, radon gas, as it comes up, it disperses through the ground and comes up. So it's something that's naturally occurring, it happens. And sometimes, depending on the way that the different layers are built underneath the home, it can channel up into a home. So generally, the reason that we get it coming up into a home instead of dispersing is due to layers of rock that have fissures, right? So that radon will come gather into fissure, collect, and then come up through that fissure and then direct up higher instead of dispersing out like it should. So with radon testing, the type of testing that is done in America for radon testing for real estate transactions only is a very, very short window. It's like 48 to 72 hours is all that's required. So this is called snatch sampling. It's just a very small window. So in Ireland and in other places and like in government buildings, when they're going to test for radon, they will do a minimum of 90 days. They want to get a full average of what's there and all that kind of stuff. So, with radon testing, generally before radon mitigation is required by law, it needs to have 2 positive tests, not 1. A lot of times we'll get 1 test, everybody will do it. And especially if the home is a vacant home that people aren't living in, they're not using the ventilation system correctly, they're not opening and closing doors. Those levels can be higher than they could pass that level where they say that it's safe. So radon is a federally regulated radioactive gas. So there is a federal standard for this. It has a set standard and households can take care of. So as you guys do these negotiations, if radon does come up, it is something that a lot of times it is worth your clients getting a second test. You get 2 positives before they spend the money on mitigation work on it. So, radon mitigation. So the way that we take care of radon gas is we put down a series of perforated pipe in the floor with a small vacuum, and then they seal 10 mil vapor barrier, which is almost twice as thick as standard vapor barrier in a home. And they're going to seal the ground, and they're going to pull negative pressure or a vacuum underneath that vapor barrier to collect whatever comes up through the ground, goes through a ductwork, sealed ductwork, and then is ejected outside. So it's a pretty simple process to install it most of the time. Sometimes under concrete slabs, it can be a little stickier than that. But it's not super complicated on how it's done. So also very fixable, especially with crawl space homes and taking care of that kind of stuff. So, then there's the testing with that, and then the fan systems themselves are generally a constant running fan. They're very quiet, and then they come up and out and stuff like that. So, that's radon. Is there any other questions about radon you guys might have? Nope. Cool. That's crazy. That's radon. All right, what else did I have in here? Okay. Cool, let's talk about joists and stringers a little bit. So floor joists and stringers are components in a home. So floor joists are gonna be the boards that your floor, subfloor, your floor structures are put on. They generally run horizontally straight across like this, right? So they're part of the structural member of the home. And a lot of times in crawl spaces, they get cut by plumbers. Generally, most floor joists can be sistered and repaired in place or boxed out. And it's not a super big fix to get those things repaired down the road. So, yeah, so that's floor joists. Stringers are gonna be what goes underneath the set of stairs. So that diagonal board that comes down that all the stairs are cut into, that's gonna be your stringer. And so those are generally inside a home. There's not much you can do with those. Outside decks, porches, that kind of stuff, we do tend to see them getting rotted out a little bit and that kind of thing. Having a stringer that is not cut right is usually what throws off the run and rise of your staircase, right? So that's how high the stair is and how far the stair comes in, so your run and your rise. So if you do have older staircases and they're talking about having to redo that, they generally have to redo the stringers and stuff like that. So other components in subfloor framing and stuff like that are going to be support posts. So support posts are going to be just either a 4x4 or 4x6, 6x6 post that sits on a concrete foundation, is anchored to that, and then comes up and supports a beam, which is what the floor joists sit on. So the other way that they frame up the underfloor spaces is with pony walls. And so pony walls are just like a short 48-inch or lower, generally sized wall that runs down instead of support posts or beams in the crawl space. Both floor structures are equally strong. A lot of times the reason that they do the pony walls is that you do tend to get a little bit less flex in the floor with it, just because you've got more contact with a solid concrete footer instead of the pads underneath the support post. Okay. Cool. One last thing on the notes here from Amanda, and that was, what are some of the most common things that I see on home inspections that are missing? So, number one, anti-tip devices on stoves. Hands down, nothing even close. Yeah, super easy to install. There's a really cool way to install those that I learned from a landlord a while back, because they're kind of a pain to get lined up. But if you take and sprinkle baking soda or baking powder on the floor, and you know where the device should go about, and then you slide your range in, you pull it out, the foot on that range is going to leave a mark in the white powder on the floor. And then you can use that as your stencil to attach your anti-tip device. You get it done in one shot instead of 6.
Years ago, I said, I looked at the home inspector and says, why the hell do we need one of these? And then he gave me an explanation. I want to hear your explanation, but I thought his was quite common.
The reason that they're there is because children climb on the front of ranges and pull them over.
And if they pull the top down and then jump on
The open door,
the open door, here
it comes over. Yep.
Yeah,
No, it is.
That's it. What logical kid would do that? I said, kids.
Single one. Yeah, that's just it. No. Not the slightest.
But that's why we have to have.
That's why we have them. So,
Yeah.
the other thing that I see a lot is CO detectors not placed correctly. So CO detectors need to be within 15 feet of each bedroom door and on each floor. So that can include split level homes. If you got like a hall home that's got technically 3 levels, there will need to be 3 CO detectors installed there and that kind of stuff. So, I see missing GFCIs in kitchens where people will put in like USB outlets and they won't daisy chain them together properly. I see a lot of missing GFCIs. I see a lot of unsealed vapor barrier in crawl spaces. That's another thing. What are other big things that I see a lot? Silicone around bathtubs and sinks, that kind of stuff that always gets old and should be replaced. Every 3 to 5 years, you should be redoing your silicone. I see a lot of loose or missing earthquake straps on tanked water heaters. So these are metal straps, they're about 1 inch thick, What they do is they lag into or bolt into the frame of the home, and it keeps the water heater from moving in seismic activity. Get that here in Alaska. So that's important because it can damage the copper lines that bring the water to the tank. Also, it could potentially, if it's a big enough deal, it can break off either the natural gas line or the electrical water heater. So if it's a tanked water heat or tankless water heater or a combi unit that's wall mounted, it does not require those straps. So that's there. And then I see a lot of failed garage doors with safety tests. Mostly it's the pressure test, which is where when the garage door is coming down, catch the bottom of the door, and with 10 pounds or less pressure, that door should release and reverse and then come back up and retract itself. So especially on older homes that are 15 or so years old, a lot of times that pressure is not adjusted correctly. Most of the time, that's an adjustment of a pressure screw on the opener. So we're just talking 15 minutes and just adjust it, test it, adjust it, test it, and then they'll let you guys know what that. So, what else do I see a lot of? I see a lot of missing handrails. People do updates to their staircases, don't put the handrails back, don't attach them correctly to the wall. I see a lot of decks that aren't properly bolted to the home structure. So when you do a ledger board, which is where the deck floor joists part that the deck planks are put on, when they attach that to the home, that does need to be lag bolted into the home. So I see that that's missing a lot. Also another pretty simple fix to install, well, depending on the type of deck, but just lagging that back into the building itself. So that's pretty much what I got for you guys. Is there any building components that you guys need more information about at all or anything like that? Cool. Great. Sweet. So,
Buddy, we
thanks guys
had
for
it
your
on
time.
mute here. I was talking away. Now we're looking,
Go ahead, Brian, what you got?
we're good. We're good.
Cool. Right on.
Thank you, buddy. I
So
appreciate
guys,
it.
if you guys get stuff on repair amendments and you don't understand what this component is or what it means, you guys have got my cell phone numbers. I've got cards at the offices. I am always happy to answer those questions, even if it's not on one of my reports or anything like that. Sharing information is super important. I love to teach people about just what I do in home inspections and help make your guys' job run a little bit smoother. So thanks again for your time. Enjoy your afternoons and we'll see you guys next time. Thank you.
Thanks, buddy.